we are starting on our second episode of AI, machine learning, deep learning. Let's start.
There are many key algorithms are there in the machine learning because that make the um, this machine learning powerful because they leverage the data effectively from the real world scenario. So we'll quickly see some of those algorithm. Like regression is there, which is like linear regression, bridge or lasso. Classification is there in which you regression, decision tree, random forest. Then the clustering is there, which is k-mean, db scan, density-based spatial clustering of application with noise, a dimensional reduction, which is PCA, where try to reduce the features or the points which are not that much important, and still try to maintain the key features and then trying to arrive at something. Ensemble method is like random forest, XGBoost, AdaBoost, which are there. So if you say some example of that, linear regression is like, which is sort of, as the name suggests, predict continuous values based on the linear relation. It means solve of price of the house prediction based on the size and location. So if 1,000 square feet cost you, whatever, $1 million, so 10,000 square feet will be $10 million, something like that. Logistic regression is like, it says with the help of sigmoid function, it's a binary, like yes, no. It's email is spam or no. Decision tree means divide the data into various branches for taking the decisions. So loan approval. So there you see if the customer, let's say, is a salaried person and has earlier paid all his credit card bills and dues and whatever, has not any loan outstanding. And so, no, if you notice, these are the points by which you add it up, which are become branches, and you take the decision. Random fraud arrest is like ensemble of decision tree to improve accuracy. So fraud detection in credit card transaction, because there's not a single pattern, but you try to arrive at various patterns, various decision trees to arrive at a card transaction, because fraud can happen based on the let's say you will try to figure it out if the location from where the transaction is happening is not okay, or maybe the amount looks suspicious, or the beneficiary looks suspicious, or things like that. So if you notice, each one of them itself can contain a decision tree, and that's where the ensemble of decision tree, and by this you'll try to arrive at fraud detection. K nearest neighbor is like you do the classification based on the closest group, means a recommendation system, and based on you see maybe suggesting product because it is near that near the value of K, whatever that K value is there. And SVM is support vector, a machine which find the optimal hyperplane for classification. So again, it's a face detection in various images. Images are there in which some faces are there, and some other that image contains some other objects also. So to identify the face, that is where the, let's say, the support vector mechanism will come into picture. The various type of tasks which happen in machine learning. One is of course the prediction task, like stock price prediction, weather forecasting. Then classification task, which is spam detection, image classification. Recommendation system, which we have seen maybe on a e-commerce platform or OTT platform, where a product or movie is recommended based on your earlier purchases or the people who have bought like you. So like you are in the zone of K, whatever we talked of KNN. So somewhere if it has been identified that there are person A and B, both have watched two types of movie and not watched some third type of movie. So now they are quite similar, because what they have watched was same, as well as what they have not watched is also same. If they figure it out, then it means they go into that cluster. After that, it may be little easy to predict that now if person A watches some third type of movie, it means the second person will also watch, because what they are watching and what they are not watching, or let's say what they are buying and what they are not buying, is similar. So based on that, you arrive at the recommendation thing. Then the sequence tasks are there, which is machine translation and speech recognition. Now we'll come to the deep learning. Deep learning, as we said, it's a subset of machine learning which use the neural network. So idea here was that what everybody thought, or maybe the researchers and scientists thought, the most intelligent species on this planet is a human, and if we mimic the way human brain works, which is consisting of various neural networks, so if we can mimic that, maybe we can generate something more than that. And Gen AI is, of course, uses deep learning model, which is transformer and GAN. And or remember, because many times the confusion happens that machine learning is supervised learning or unsupervised learning, but these are learning paradigms. So there are various, and these are like some of them I have mentioned here: supervised, unsupervised, reinforcement learning, supervised learning. Now, there are certain technical challenges in machine learning to start with. One is which is called overfitting. In the sense, like simply, if we take the example of linear progression, where we said the size of the house and the location of the house determine the price. So these two data points are fine, but suppose somebody is including the color of the bathroom in those houses to determine the price of the house. So that is like that data point can be overfitted, and that is what the model will called overfitting, because it may not be, maybe for one or two houses, maybe the color of the bathroom may be determined, but it may not be true for all the houses. But if your model is taking into consideration data points like this, that is what is called overfitting. So there is a chances of overfitting, and that will lead to the poor result. The other is, of course, the poor quality, and that is the ensuring that data is clean and representative. So no overfitting, but it represent, and so diverse enough the data is there. Similarly, the computation resources which are required, the memory power which is required in the machine learning, again, that one need to take into account. Definition of deep learning, if you see, it's like it's a subset of machine learning utilizing artificial neural networks to mimic the human brain. The functionality of artificial neural network is it process data in interconnected layers, and deep processing strength it has. So it's like a deep learning, different layers are there, and through which you pass the data, and it get interpreted the way our mind reads the data. When you see a picture, so you see the edges, and then you try to arrive at the broader contour, and then the trying to understand the color. So like that it goes, and that is where the deep learning also tries to do. That is the artificial neural network, the first one. It excels in analyzing large volume of unstructured data such as images, speech, and text. Of course, there is a many use cases are there, including self-driving car, where deep learning perform object detection and decision making. It does impact on technology and deep learning, like it significantly impact various fields, including healthcare, finance, and autonomous vehicles. So neural network are the main components of deep learning. We can say foundational structure on which, be it a deep learning or the Gen AI, those are sort of underlying foundation structure is neural architecture. Techniques is backpropagation and dropout, and then mathematical formulations are there. Then you do hyperparameter tuning, in the sense you arrive the weight and biases, and based on that you keep on tuning. This foundational structure include, apart from the ANN, the CNN is there, which is for use for images, and recurrent neural network for sequence data, means speech, because in that the sequence matters. A1 against B or B1 again, they change meaning differently, totally. It changes the thing. So sequence of data is very important. And a transformer again are used for natural language processing. And each architecture that will serves the specific type of data task and your use case. So neural network consists of, the picture here shows the like interconnected layers of neurons, which contains activation functions, and in that there is a gradient descent and back propagation, and weightages are assigned. So sort of you can think of those mathematical functions are there, and the weightage is assigned. And again, deep learning also implies supervised and unsupervised learning, leveraging deep data insights. And one of the things is like face recognition technology, which is used in the smartphone. So, ANN is artificial neural network, basic feed-forward network with a fully connected layer. CNN helps in the for the images, and RNNs in the sequential data, which try to remember the previous input, and that's way, let's say, the language translation works. Apart from that, there are other models also like LSTM, which is like improved RNN with the with the long-term memory capability. So that way it remembers, and the bigger passages can be translated, and speech recognition could have been done. Generative adversarial network. Now, this is one of the important thing which came in 2014, and here two models are there who. So one model try to create an image, and second model try to figure out the problems in that image, and based on that, whatever the objection raised by the second model. First model again try to improve on that, so that way new data get generated. We can say the word generative, that is where the first time was used in 2014, and it tried to create the realistic deepfake videos. And then the transform model, which we will discuss further also, it uses a self-attention mechanism of parallel processing of sequences. uh, Deep learning contains many important library. One is the TensorFlow, which is used in image classification in healthcare diagnostic. PyTorch, which is the torch method written in Python, and Keras is there, which is high-level API running on top of TensorFlow, very user-friendly. Like it's used for handwriting recognition. And then apart from that, YOLO is there. You look only once. Uh, you only look once, and it's for again for the real-time object detection with very high speed and accuracy. In the surveillance system, while you're monitoring the crowd, or when in the car, so that time you need a quick decision with very high speed and accuracy by quickly looking at it. Apart from that, cafe is there, which is efficient and fast, suitable for image classification tasks. MXNet is there, which is again scalable, support multiple languages and GPUs. So these are like recommendation system for e-commerce platform. Uh, Now let's understand how deep learning differs from the machine learning. So remember, first we talked of the expert system where the coding used to happen, or the expert system where there, where rules were defined and sort of static rules were there. Then machine learning came in, which we said will provide you the data, and still will do the feature engineering. So we'll still tell that, yeah, it's the image of cat, and that cat contains two eyes and things like that, and you generate the code accordingly. So it means you require the feature engineering. That is where the traditional machine learning relies on manual feature engineering. Deep learning extract those features, those multi-layer neural networks extract those features. So you don't require feature engineering or that with the domain expert guy into the deep learning, because here the machine learns based on the data. It figures out those features, it extracts that features from the multi-layer neural network. This is the most important thing, which where deep learning is, let's say, that's part of the machine learning, but how it differentiates, or where the advantage it comes. So to put it other way, traditional machine learning required domain expertise. Deep learning automatically extract the feature from the raw data. Of course, then what it means, traditional machine learning learner standard CPU, deep learning required GPU, TPU, cost of training, while in the traditional machine learning is low in training cost, in the deep learning goes up. And In the optimization techniques in the traditional machine learning uses algorithm like gradient boosting. Deep learning employs backpropagation and gradient descent.
Understood now the machine learning and deep learning and the concept behind that. So this complete our second episode. If you like this episode, like my channel and share this video. Thank you.